So a hyperbolic paraboloid as a surface of translation. So basically I am translating parabola ABC along parabola CE with the vertex at E, and I'm translating this or sliding this along this parabola which has upward curvature compared to ABC which has more downward curvature, and this is going to give us the resultant parabola DEF, which we can't actually see the profile of it here, but we know its width and its height from our end elevation plan. So basically, to get my first parabola ABC, I just constructed using the rectangle method, dividing up our sides. Here I divided up into 5 parts, self-explanatory. I was given my overall height and my overall width in the question, and I was also given the height of my smaller parabola, which was the height of my translated parabola. From this, in my end view, I was able to construct the parabola, or just semi-parabola if you like to call it, CE, using the same method again, the rectangle method, except this time I only use half of a, compared to this side I had 2 halves of the parabola. Then working down for a plan view, I knew my height here, so my height just said my distance DE here, I was given that in my question. So what I did was I brought this down from my vertex of my larger parabola, from C, and I got this line here. And where this line crossed my parabola, I brought this down to my XY line, across down a 45 degrees into my plan view, and across, and this gave me my width of my the width of my translated parabola in plan view. So the outer sides of the hyperbolic paraboloid are actually hyperbolas rather than parabolas, hence the term hyperbolic paraboloid. So again, then I just drew 2 hyperbolas rather, using the rectangle method with my vertexes at D and E, and kind of similar construction to the parabola, except my vertexes, I used the opposite vertex rather than the nearer one. So yeah, that's a hyperbolic paraboloid as a surface of translation.